Hi, in this video we're going to look at what we mean by parallel and perpendicular lines. Let's look at parallel lines first. So here we have a line. Okay, we can say the gradient of this line is actually 2 because every 1 square along it goes up 2, so it will be something like that is the line y is equal to 2x. Now if we move C, we get another line which is parallel to it. What we mean by parallel lines? Well, the parallel lines never get any further apart or any nearer. They're always exactly the same distance apart. Alright, and this new line will have a equation y is equal to 2x, same gradient, plus 1. The gradient's 2, but now goes through C is 1. Okay, and we can get a whole family of these curves. So all these lines here are what's known as parallel lines. And if we go back the other way, we can get some going that way as well. Okay, and what do we notice about them all? We notice, if you look at the equation, it's always going to be y is equal to 2x and then something. Okay, and so what we can say about parallel lines is that parallel lines always have the same gradient. So to prove that two lines are parallel, all we've got to find out is if the two gradients of the lines are exactly the same. Right, now what we're going to look is at two lines which are what's known as perpendicular. Now if they have to be seen as perpendicular on the graph, then the axes have to be in the same aspect, i.e. that distance there has to be the same as that distance there, otherwise we cannot see the lines looking perpendicular. Now perpendicular means that the two lines are at right angles to each other. So here we have the line y is equal to x plus 1, and the blue line is the line y is equal to minus x plus 3. Now if you take the gradient of this one, which is minus 1, and the gradient of this one, which is 1, we don't write the 1 in, then we can see that the product, the multiplication of them, 1 times minus 1 is minus 1. And so therefore, if one gradient has one line has a gradient m, the other line will have a gradient minus 1 over m. Let's just change the value of m to something like 2. Okay, so what we got here is this has a gradient of 2, and this has a gradient of minus a half. They're still perpendicular to each other, so we have 2 times minus a half, or minus 1 over 2. So if one line has a gradient m, then the perpendicular line will have a gradient minus 1 over m. Okay, and what can we say about perpendicular lines? Well, this is the rule. If a gradient of a line is m, then the gradient of a line perpendicular will always be minus 1 over m. Okay, if it was to make m negative, same idea works. Okay, but the angle now it's still 90 degrees. This is still 90 degrees. Let's not do minus 1. Let's do something like minus 2. Okay, so this one has a gradient of minus 2, and then therefore minus 1 over minus 2 is actually a half, okay, and again if you multiply these together you get minus 1. So what you should do, once you've got your gradient of your perpendicular, is you should multiply the two gradients together just to check that you actually get minus 1. So the general rule for parallel lines is that the gradients are the same, and if lines are perpendicular, then they are, if lines are perpendicular, then they have the product of their gradients is going to be minus 1. Okay, so just put that back like that. Okay, so this has been a video to show you about the conditions for parallel and perpendicular lines. I hope you've understood, and I thank you very much for watching.